Hello everybody. In this video we are going to solve problem number 2.29 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. So this is the circuit given in which all resistors values are 5 ohm each. So this is our problem statement. We have marked all the resistor values as 5 ohms and we are asked to find the R equivalent when you are looking into this circuit. To find the R equivalent, we have to start from the opposite end, that is the right end. And we identify these two resistors as series resistors. But how actually you identify them as series resistors? Here you have a common connection between these two resistors. That too only one common connection. The other end or the other arm of these resistors are connected to some other resistor or to the reference node only. Technically speaking, the same current will be flowing through this path in which these two resistors are being connected. Then we say that these resistors are series resistors. And in order to find out the equivalent of these two series resistors, just sum them up. So 5 ohm plus 5 ohm will give you the equivalent value, that is nothing but 10 ohm. Now we have to replace these two resistors by a single resistor of 10 ohm value. Actually in this circuit we have 6 resistors initially given. Now by replacing these two by a single resistor, we get a modified circuit with only 5 resistor values. So now we got this 10 ohm in this modified circuit. Now we are moving on to the step 2, in which now we have to find out the equivalence of these two resistors. This is 5 ohm resistance, this is 10 ohm resistance, and these two are connected in parallel. But how do we say that they are connected in parallel? When you have these resistors in which both arms, this is your first arm, they are common. Similarly, here you have your second arm of these two resistors, they are also having the connectivity. Then we say that they are parallel resistor. Technically speaking, when different currents are flowing through this two resistors, we say that they are parallel resistors. So we can calculate the R equivalent for these two parallel resistors as the product of these two resistor values divided by sum of these two resistors. So it is 50 divided by 15. So we get the value as 3.33 as the equivalent for these two resistors. Then we can replace these two resistors by a single resistance of equivalent value 3.33 ohm. So that now we get another modified circuit in which we have only 4 resistors in which this equivalent resistance value is 3.33 ohm. Now we move on to step 3, in which we are going to find the equivalent of these two resistors. This is 5 ohm resistor, this is 3.33. So they are series resistors, so the equivalent value is just the sum of these two. So it is 8.33 ohm. Now we get the modified circuit in which these two resistors are replaced by a single resistance of value 8.33. So that this modified circuit has only 3 resistances. In step 4, we are going to find out the equivalent value of these two parallel resistors. So how to find out or how to calculate the equivalent value? It is the product of these two values divided by sum of these two values. So it is 41.65 divided by 13.33. So its equivalent value is 3.125 ohm. So now we replace these two values by the single resistor value of 3.125. Now in this modified circuit only we have 2 resistors. Okay, so we are moving on to step 5, in which we need to find out the equivalent of these two. So these two resistors are connected in series because same current will be flowing through these two resistors. So just we have to sum them up. So we get the value as 8.125 ohm. So this is the final modified circuit or final equivalent circuit in which we have a or equivalent value of 8.125 ohm. So this is our answer. Hope you have understood. Thank you for watching.